Hello students, in this video session I'm going to demonstrate how to convert a binary number into a denary number. To demonstrate this example I'm going to take a binary number like 1101 base 2. Okay, fine. So always this binary number will be coming with base 2. Okay, to solve this problem, what is the first step you have to do means you have to draw a binary table, the one like this. Okay, now what is the next step you have to do means you have to fill the first row with the numbers like a 1 2 4 8. Okay, so how actually I got these numbers. It is simply the powers of 2. Say for example 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. Okay, fine. Now what is that next step you have to do means you have to fill the second row with these numbers, means the binary numbers. Say for example like a 1101. Okay, and now what you have to do means you have to see where the 0 is there. So here in this column the 0 is there, isn't it? 2 to the power 1, the 0 is there. So what you have to do means you have to strike that column. Okay, now the final step is you have to add actually what is on the top. Say for example like 8 plus 4 plus 1. You should not take 2 because already actually we strike out that one, isn't it? So now you have to add this one like 8 plus 4, it is 12 plus 1, it is 13. Okay, 13 base 10. This is our final answer. Okay, fine. I'm going to demonstrate one more example. For this example I'm going to take the binary number 11001 base 2. Okay, this is the binary number I'm going to solve, means to convert from binary to denary. Okay, so what is the first step you have to do means you have to draw a binary table, right? The one like this. What is the next step you have to do means you have to place the numbers here like 1 2 4 8 16 32. Okay, so what is the next step? So you have to keep actually these binary digits on the second row. So how many digits are there? 1 2 3 4 5 digits are there here. How many columns are there? 6 columns are there, isn't it? So you can start from here. Say for example like 1 1 0 0 1, but here actually one extra empty box is there, so here simply you can keep 0. Okay, no problem. In the next step you have to find the zeros and you have to strike out that specific columns, isn't it? So here 0 is there, you can strike out that one, this one you can cut, and this one you can strike out. Okay, then remaining say for example like 16 is there, 8 is there and 1 is there. So you have to take that numbers 16 plus 8 plus 1 equal to, so 16 plus 8 it is 24 plus 1 it is 25. Okay, based on this is our final answer, right? Hello students, in this video session I'm going to introduce the topic hexadecimal number system. What is meant by hexadecimal? It's a system of numbers with a base of 16. Means a number which is coming with base 16, we can tell that number as the hexadecimal number. Usually the units will be increased by the powers of 16. Okay, so the example you can see here like the hexadecimal numbers usually 0 1 2 3 4 5 6 7 8 9, and after 9 instead of 10 the denary digit instead of 10 here, what is the character there means A B C D E and F will be there. So totally how many digits will be there means 16 digits will be there. How many digits will be there? 16 digits. Usually the hexadecimal number, the numbers it will be coming with base 16, and how many total number of digits will be there means 16 digits will be there. Okay, basically you should know what is meant by debug also. What is meant by debug means it is just finding and fixing the problems and errors in a program. When you are writing a program, in case if any errors are there, So you are going to find that error and you are going to fix that problem. That actually we call as a debug. Okay. Basically, the computers do not actually understand the hexadecimal numbers. Directly, it can't understand the hexadecimal number. It must be converted into binary before processing. Okay. Usually, the programmers work with hexadecimal numbers because for the humans, the hexadecimal numbers are very easy to read actually than the binary numbers. And also, these hexadecimal numbers will be shorter than the binary numbers, and also easily you can read and understand. It is not difficult like the binary numbers, zeros and ones. Okay. Programmers, when they're writing the programs, if any errors are there in the program, it's to debug actually these hexadecimal numbers are very easy to fix the errors. Okay. Usually, the computers they will convert the hexadecimal data into the binary numbers before going for processing, because the binary numbers usually the computers can understand only the binary digits like either 0 or 1, right? The hexadecimal notations are used in HTML programs. The programmers while writing program, they are using the hexadecimal notation for colors. And also, the hexadecimal notations are normally in 6 digits. The one like this, like double F, double A, double 3, which represents the orange color. And moreover, in hexadecimal numbers, the first 2 digits of red component and the second 2 digits of green component, the last 2 digits of a blue component. Okay, so all the three together creates the orange color, and for this one is for the black color. Okay, hexadecimal notation are used in standard Windows error messages when you are using the Windows operating system. Okay, if something goes wrong, actually it will be giving an error message. So usually these error messages also will be displayed like in the form of like hexadecimal notations, and also it is used in MAC addresses like media access control. Usually sometimes it will be coming in 12 digits or sometimes 14 digits will be there. So they are actually the 12 digits, or either it's 12 digits or 14 digits. It would be in like hexadecimal notations. Okay. Hello students, welcome to this session. In this demonstration, I'm going to discuss how to convert a binary number into a hexadecimal number. To demonstrate this one, I'm going to take a binary number, say for example like 110001111 base 2. Okay, I'm going to take this binary number. So to solve this one to hexadecimal number, first you have to draw a binary table. Okay, the one like this. Okay, now what you have to do means you have to split this one. So how to split this one means from the right hand side, actually, say for example 1 2 3 4. Okay, you can keep a vertical line here. Okay, then 1 2 3 4. Okay, so you can keep a line here. Okay, now what you have to do means on the top of the row you have to keep the numbers like 1 2 4 8 and 1 2 4 8. Okay, so you know how I got this one. This one is 2 to the power 0, 2 to the power 1, then 2 to the power 2. This one is 2 to the power 3. Same like this, this one is also like 2 to the power 0, 2 to the power 1, 2 to the power 2, and this one is 2 to the power 3. Okay, so now what is the next step you have to do is you have to distribute this number. So from here, say for example like 1 1, 0 0 0 triple 1. Okay, now the zeros you have to cross out. Where the 0 is there, this one is 0, this one is 0, this one. So you can cross out this one, then this one and this one. Okay, now remaining what is left, say for example here 4 is there, isn't it? 4 2 1, then you have to add these 3. So say for example 4 plus 2 plus 1 equal to, it is 6 plus 1, it is 7, right? Now the next one here, it is 8 plus 4 equal to, this will be 12, right? Here my intention is to convert this binary number to hexadecimal number, right? Here see, I got two numbers. The first number is 12, it's a Deanery number, and the 7, it's a Deanery number. So you have to find, for this 12 you have to find out the hexadecimal number. Okay, in hexadecimal number the numbers are like this. In say for example like 0 to 9, then it is A, B, C, D, E and F, isn't it? So this is 10, this one is 11, and this one is 12. So 12 means it is C, isn't it? But 7 it is also. When you are going to write the answer, you have to write like this: C7 base 16. This is our final answer, right? Okay, let us see one more example to convert a binary number to a hexadecimal number. Okay, so for this I'm going to take a number like 1 0 1 1 1 0. Okay, this is the binary number, it's base 2. So I'm going to convert this binary number to a hexadecimal number. So first of all, what we have to do means we have to draw a binary table, right? The one like this. Okay, now what we have to do means we have to split this off from the right hand side, 1 2 3 4. So we have to keep a line here like this, then 1 2 3 4. So you have to keep a vertical line here. Now from the right hand side you have to write 1 2 4 8. Okay, 1 2 4 8. So you know how I got this one. It's simply the powers of 2 to the power 0, then 1 2 3, like that. Okay, now what you have to do means you have to distribute the numbers here. Say for example like from the right hand side you can write like 0 1 1 1 10 0 1. Okay, so only 6 digits are there in our question, so remaining 2 empty boxes are there. Simply you can keep 0 there. Okay, how to identify the zeros, and you have to cross out that one, isn't it? So from here, this one you can cross out, this one we can cross out, this one we can cross out, and here this one we can strike out, right? So now see the numbers left on the top. Say for example for this one 2 is there, as a and 8 plus 4 plus 2 is there, so you can take 8 plus 4 plus 2, right? So this will be 2, and this one is equal to 12 plus 2, it is 14, right? So here our intention is to convert the binary number to hexadecimal number, and here the Deanery number 2 is there, here 14 is there. So now you want to convert this one to a hexadecimal number. Hexadecimal, you know, like starting from 0 to 9, then A is there, B, C, D, E, and the last one is F. So completely 16 digits will be there, isn't it? So now you can write 2 as it is, you can write. Okay, in hexadecimal number 2 is there. Then for 14, what you will be writing for 14? So here this one is 10, 11, 12, 13, 14. So 14 is E. So it is 2E base 16. This is our final answer. Okay. Now let us see how to convert a hexadecimal number into binary number. Okay. To demonstrate this example, I'm going to take a hexadecimal number B C8 base 16. You know, always the hexadecimal number will be coming with the base 16, right? The very first step you have to do is take the individual numbers, okay? Say for example, the first number is B, the second one is C, the third one is 8. Okay, fine. Now what you have to do means, on the top of this number, you have to keep the number 1, 2, 4, 8. Okay, same like that here. 1, 2, 4, 8. And here also the same 1, 1, 2, 4, 8. Okay. Now keep the Deanery number for this hexadecimal number below this alphabetical character. For B actually it is 11 and for C it is 12, but 8 it's 8, no change in that one, right? Okay, fine. Now the next step is very important. Okay, so now I'm going to construct this number by picking the numbers from this list. Okay, so to construct this number I have to take 8, right? So on below that 8 you have to keep 1. So remaining all the 3 numbers I'm going to place 0. That's all. Now I have to construct this number, means 12, right? To construct this number I have to pick the numbers from here. So 8 plus 4 it is 12, right? So under that 8, 1 and 4 you have to keep 1, remaining 2 you have to keep zeros. That's all. Now I have to construct 11. Okay, to construct 11 I have to pick 3 numbers from here. 8 plus 2 plus 1 it is 11. So I'm using the number 8, so keep 1 here. I'm not using this number, so we have to keep 0 here. I'm using this number, I'm using this number. Okay, that's all. Now how to write our final answer means, from here I have to start. Say for example like a 1 0 1 1, then 1 1 0 0, then 1 0 0. Okay, base 2. This is our final answer. This is the way how to convert from a hexadecimal number to a binary number, right? Okay, fine. Let us see one more example. Okay, the example I'm going to show here is the hexadecimal number like 9F. Okay, base 16. This is the hexadecimal number. I want to convert this number to a binary number. So what is the first step you have to do? So you have to take the individual numbers. Say for example 9. The next one is F. Then you have to keep the vertical line in between these 2 numbers. Now what is the next step? On the top you have to keep the numbers. You have to place the numbers like 1, 2, 4, 8. Okay, this is simply the powers of 2. That's all. Now again here 1, 2, 4, 8. Okay, so what is the next step? In the next step you have to construct these numbers, isn't it? So you want to construct this number. This one is F, means it is in hexadecimal. F actually it is the Deanery number, that is 15, right? Okay, now I have to construct this number. To construct this number, what I have to do means I have to pick the numbers from this list, isn't it? So 8 plus 1 9. So I'm using these 2 numbers, right? So for that, what you have to do, below this 8 you have to keep 1. Then this one I'm not using, this one I'm not using, I'm using this one. So here you have to keep 1, right? Now here 15. 15 means here 8 plus 4 it is 12, plus 2 it is 14, plus 1 it is 15, right? So I'm using all the numbers. So you have to keep 1 1 1 1. That's all. Now how to write our final answer means like 1 0 0 1, then 1 1 1 base 2. This is our final answer. Okay. Now let us see how to convert from hexadecimal number to a denary number. Okay. To demonstrate this example, I'm going to take a hexadecimal number which is A, D, then 4. Okay. Base 16. So this is the hexadecimal number. I want to convert this hexadecimal number into a denary number. Okay. So here the very first step what you have to do means take this number. Now place the number like 16 to the power 0 here, then 16 to the power 1 here, then 16 to the power 2. Okay. Now place the denary value for this A here. What is the denary value for A? Actually that is 10. And for D it is 13, and 4 always in hexadecimal it will be 4, right? Okay, the next step is very important. So what you have to do here means take this number 4 times, you have to put this one here, means 16 to the power 0 means it will be 1. So any number to the power 0 it will be 1. So you can keep 1 here. Okay, keep this one inside the bracket. I have to take this 13. 13 times 16 to the power 1. So 13 times 16 to the power 1, it is 16, right? So you have to keep this one, okay? And after this you have to keep the plus sign, okay? Now take the last number. What is the last number? That is 10. 10 times 16 to the power 0, it is 256, right? So keep this one inside the bracket and we have to keep the plus sign. So now we have to calculate all the 3 values which is inside the bracket and we have to add that one, okay? Okay, now 10 times 256, isn't it? So it will be 2560 plus 13 times 16, it will be 208, right? Plus 4 times 1, it will be 4. So now our final answer will be 277 to base 10. Okay, this is our final answer because we are going to convert from a hexadecimal number to a denary number. That's why the base 10 is here. Okay. Okay, fine. I'm going to demonstrate one more example. For this example, I'm going to take a hexadecimal number that is 1 CE. Okay, 1 CE base 16. This is the hexadecimal number. I'm going to convert this one to a denary number. So what is the first step you have to do? You have to keep the numbers separately. Okay, so 1, then C and E. Okay, then what is the next step? Here you have to keep the digit means 16 to the power 0, 16 to the power 1 and 16 to the power 2. Okay, if say for example one more number is there means it will be 16 to the power 3 and so on. Okay. Okay, 1 always in hexadecimal number 1, it will be always the denary number 1. Then if it is C, if it is C means it's 12, right? So you can keep 12 here. So E means, what is E means? It will be 14. Okay, fine. Now 14 times to the 16 to the power 0 means it will be 1, so you can keep 1 here. Okay, now plus means here it is 12. Okay, 12 times 16 to the power 1 is it is 16. Okay, again you can keep the plus sign here. Now 16 to the power 2, it is 256. 256 times this one is 1. Okay, 1. Okay, now the next step what you have to do, you have to find the value for this one which is inside the bracket. So 256 times 1, it is 256, plus 12 times 16, it is 192. Okay, plus 14 equal to, you will be getting the final answer, that is 462 base 10. This is your final answer. Okay. Okay, in this session I am going to demonstrate how to convert from a denary number to a hexadecimal number. Okay. To demonstrate this example, I am going to take a denary number 2004 base 10. Okay, this is the denary number. I want to convert this one to a hexadecimal number. Okay, the very first step you have to do is take 2004. Okay, how to divide this one by 16. You have to divide this one by 16. Okay, first take these two numbers 16. Okay, so 1 times 16, it will be 16, isn't it? So 20 minus 16, it will be 4. So now here 1 0 is there, so it will become like 40, right? Now 2 times 16, it will be 32. 2 times 16, it is 32. So 40 minus 32, it will be 8, right? So you can carry that 8 here. Now this will become 84, right? Okay, now 5 times 16, it will be 80, isn't it? So 84 minus 80, you will be getting the balance 4. So you have to keep the remainder here. Always you have to keep the remainder here. Again, you have to divide this one by 16. Okay, so until you get a number less than 16, you have to keep on dividing. Okay, now 7 times 16. Okay, 7 times 16, it is 112, means 112. So you have to subtract that 112 from 125. So you will be getting like 13. Okay, so now you can stop. I told once you get a number less than 16, you can stop that. So now how to write your final answer, means from here you have to go and you have to write like this, means like 7, 13, 4. Okay, so our intention is to convert actually a denary number to a hexadecimal number. So this 13 in hexadecimal, it will be D, right? Okay, so our final answer is 7D4 base 16. This is our final answer. Okay.